Hello friends, today's question. Water flows into a large tank with a flat bottom at a rate of 10 to the power minus 4 meter cube per second. Water is also leaking out of a hole of area 1 centimeter square at its bottom. If the height of the water in the tank remains steady, then this height is. So it is given that we have a water tank, and this water tank is leaking through a hole which is at the bottom. So let us suppose somewhere the hole lies here. And we are given the area of cross section of this hole, and let us suppose this is the height of the water. Let's this height be h, and we have water which is you can say water is flowing into the tank also. So let us suppose water is flowing somewhere here, and we say the water flow into the tank is, let us suppose, given as q in, and water that is flowing out of the tank, let us suppose, is given as q out, and area of cross section of the hole is given as a, and we say that the water that is flowing out of the tank with the velocity of v. And it's said that the water in the tank remains steady. It means the water inflow should be equal to water outflow. So we start from here only. So it is given that the height of the water in the tank remains steady. So therefore, we can say that rate of water flowing into the tank, rate of water flowing into the tank is equal to rate of water flowing out of the tank. Or we can write it in terms of this q, that is q in is equal to q out. So let us find out what is our outflow rate. Outflow rate, and which is nothing but rate of water flowing out of the tank, which is our q out. And this q out we can write area multiplied by the velocity v, which is area multiplied by v, and v here, let me write a is the area of cross section of the hole, area of cross section of hole, and v is the velocity of the water flowing out of the hole. V is the velocity of water flowing out of the hole, and this v velocity of the water flowing out of the hole rather can be given can be found out by using the Torsily's theorem. Okay? Because this hole is right at the bottom and h is the height of the water, so we can say the velocity will be equal to 2gh. Okay? So therefore we can say that v is equal to square root of 2gh, and this is with respect to Torsily's theorem, Torsily's law rather. So therefore we can write that our q out will be equal to a multiplied by square root of 2gh, and we already said that q in should be equal to q out. So we can write that q in will be equal to a square root of 2gh, and q in is given is 10 to the power minus 4, This is 10 to the minus 4, and area is given as 1 centimeter square. So this becomes 1 into 10 to the power minus 4, and we have square root of 2gh. Minus 4, these two goes away. So we can write that h will be equal to 1 upon 2g, or 1 upon 2 into 9.8. So which can be approximately equal to 5.1 centimeters. We get 5.1 centimeter, and this is the height of the water in the tank. This is the height of the water in the tank. So from the options that are available to us, you can see that option number C is the correct option. So you can write that option C is correct. So this was quite easy question, directly based on, you can say, the flow equality of the flow rate and using the Torsi's law. This completes the question. Thank you.